right, unit conversions. As I mentioned when we were going through this introductory discussion, it's often necessary to convert from one unit to another, right? And there are a number of methods that you can use to convert from one method to another. Anybody ever use that method, King Henry, drinking chocolate milk, or just die drinking chocolate milk or something like that? Has anybody ever heard of the method of a kangaroo jumping up and down the staircase? Who has? Really? That's the most ridiculous method I've ever heard of. But yeah, there's tons of methods. Yeah, it doesn't. They don't make any sense to me. If you're used to those methods, that's perfectly fine. I don't care what method you use. The only problem with those methods is they only work within the metric system. So if you're converting from kilometers to meters, you can use King Henry and his chocolate milk, or the kangaroo, right? But if you need to convert from inches to centimeters, King Henry and his chocolate milk are not going to help you. So I'm going to show you a method that uses a conversion factor that can be used for any kind of unit conversion. A conversion factor is a fraction that's equal to 1 that relates two different units to each other. We want to make sure the fraction is equal to 1 because we don't want to change the amount that we're dealing with. We just want to change the way we refer to that amount. And if you multiply something by 1, what does that do to the number you multiply by 1? It doesn't change it, right? So the best way to show you how to do this is to do some examples. So let's do a few. First, let's convert 15 inches to centimeters. So when you do this, the first thing you do is you write down the number and the unit that you've got. And then you multiply by a conversion factor. It's going to be a fraction, so here's the line to separate the numerator from the denominator. Your conversion factor includes both of the units, the unit that you've got and the unit you want to get to. You put the unit that you've got on the bottom and the unit that you want on top. Then you include the numbers so that the amount on top and the amount on bottom are the same. Now in this case, this involves the English system, so I would not assume that you have this conversion factor memorized. There's a list of common conversion factors on the front cover of your book, telling you how many inches there are in a centimeter and how many centimeters there are in an inch. Okay? 1 inch is equal to 2.54 centimeters. So we would put that. So that is how we would build this conversion factor. And if you look, even though the number on top and the number on bottom are different, the amount on top and the amount on bottom are the same. So this fraction is equal to 1. Does that make sense? Then we multiply this through. The inches will cancel each other out. We'll be left with just the centimeters. And that gives us 38.1 centimeters. All right, the next one, convert 45 meters to kilometers. This is one that I would assume that you have the conversion factors memorized because this involves the metric system using only those common prefixes. So we want to convert to kilometers. So in this case, meters is going to go on the bottom, kilometers on the top. Now what does kilo mean? 1,000. So is that correct? No, it's not. But can you see how this is a common mistake? Right? These conversions are easy, and after you do a few, you'll get they'll become second nature. But this kind of mistake is very easy to make, even after you get used to doing these problems. Kilo means 1,000, so it's easy to make the knee-jerk reaction of putting 1,000 in front of the kilo. All right? But think about what this is saying. This is saying that 1,000 kilometers is the same as 1 meter. And that is not the case. This is 1 meter. 1,000 kilometers is the distance from Chicago to LA. Not even close to the same. Right? So it should go the other way. 1 kilometer is equal to 1,000 meters. Meters cancel out, and that leaves us with 0.045 kilometers. All right, a couple more. How many seconds are there in 3 hours? This is an example of one that might be best approached in 2 steps. Because you might not know how many seconds there are in an hour, but you know how many minutes there are in an hour. You know how many minutes there are in a second. So we can go through 2 steps here. First, I'm going to convert from hours to minutes. There's 60 minutes in every 1 hour. And then convert from minutes to seconds. There's 60 seconds in every 1 minute. So as I multiply this through, the hours cancel, the minutes cancel, and we're left with just the seconds. 3 times 60 times 60, that gives us 10,800 seconds. Now, if you knew how many seconds there were in an hour, then you could do this in 1 step. There's 3,600 seconds in every 1 hour, which is just 60 times 60. So you could have done this in 1 step. No big deal. Last one, how many cubic centimeters are in 1 cubic meter? So we're going to start with 1 cubic meter. Cubic meters is going on the bottom, cubic centimeters on the top. What number goes where? $100, where does the 100 go? All right. And the 1 on the bottom. Centi means 1/100th. So 1 centimeter is 100th of a meter. So is this right? If we were dealing with units of length, then this would be correct. But cubic centimeters and cubic meters, that's units of volume. So let's think about what these units represent. A cubic meter would be a box that's a meter tall, a meter wide, and a meter deep. That's a pretty big box. 1 cubic centimeter is a box that's a centimeter tall, a centimeter wide, and a centimeter deep. That's a tiny little box. Our conversion factor wants to tell us how many cubic centimeters it would take to completely fill the cubic meter. Would 100 be enough? No. 100 would just be enough to line up along 1 corner. To completely fill the box, we would need 100 times 100 times 100. This is pretty easy to remember. Since the units are cubed, the conversion has to be cubed. Right? If we were dealing with units of area, it'd be the same. We would just be squaring the unit, so we would have to square the conversion. Right? So this should really look like 1,000,000 cubic centimeters. 100 cubed is 1,000,000. 1 cubed is still just 1. So there's 1,000,000 cubic centimeters in every 1 cubic meter. So this cancels out. 1 times 1,000,000. Our answer here is 1,000,000. Right? Does that make sense? Now, this stuff should be easy. This stuff should be second nature. So, under the Chapter 1 folder, I posted some metric conversion practice. I'm not going to take that up. That's for you to work through if you feel like you need a little bit more help with this, if you need a little bit more practice. I'll also post the solutions. So that's just for you to work if you feel like you need it. Right? From now on, I'm going to assume this stuff is easy and second nature. Okay? So the next thing we want to look at is the trig review. We're going to be using trig a lot in this class, so it's important that you have a pretty good grasp of the trig tools that you're going to need. Basically, that's just understanding right triangles. If you can solve a right triangle, then you're probably okay with the trig that we're going to use. We're not going to use any of the complex trig identities like law of sines, law of cosines. There's once where we might use probably the most basic trig identity, which is tangent is sine over cosine. That one may come up, but other than that, it's basically just using the Pythagorean theorem, a squared plus b squared equals c squared, and the three basic trig functions, sine, cosine, and tangent, to solve for an unknown side if you know one side and know one angle. Okay? These equations, Pythagorean theorem and sine, cosine, and tangent, will not be on your equation sheet. I will assume that you have these in your brain. There's all kinds of mnemonics to help you remember these. Oscar had a heap of apples is probably the most common one. That's the one I use. Every time I sit down to work physics problems, I have to say Oscar had a heap of apples in my head. I've been doing physics for like 15 years, and I still have to say that. There's others. SOHCAHTOA, anybody ever use that one? So, there's sine, cosine, and tangent. Everybody remembers that order for whatever reason. So, Oscar had a heap of apples, or SOHCAHTOA. Another one that the math teacher that I worked with back when I was teaching high school used to teach her high school students this was some old hippie caught another hippie token on acid. Yeah. A high school teacher using hippies doing acid to teach trig. Anybody ever heard that one before? Yeah. It's more, huh? Tripping. I guess you don't toke acid. You trip on it. Yeah. Hey. How would I know these things? But you can use whatever method you want. I don't care. But I do want to work a couple of examples, and like the metric conversion practice, I've posted some trig practice. So you can go through and work a few right triangles to brush up on these skills. Because this is another thing that from now on I will assume that is second nature to you. Okay? So let's do a couple of examples. With the right triangle, you can have, there's 5 things that you could be asked to find. 2 angles, because you know the third is 90 degrees, and 3 sides. If you know any 2 things about a right triangle, you should be able to solve for the remaining 3. Okay, so in this case, we know 2 sides. We're going to find the other 2 angles and the unknown side. Doesn't matter where we start here. I'm going to start off by solving for the unknown side, C. Since we know the other 2 sides, we can use the Pythagorean theorem for that. So A and B are the 2 legs of the triangle that are not the hypotenuse. The hypotenuse is the side across from the 90-degree angle. It doesn't matter which one is A and which one is B. So here we want to solve this for C, so we'll take the square root of both sides. So C is the square root of A squared plus B squared. In this case, let's say A is 12 meters and B is 8 meters. I think I just wrote them in the opposite order that I just said, but like I said, it doesn't matter. So when we work this out, we get that C is equal to 14.4 meters. Take care for order of operations. Make sure you do everything under the square root first, and then take the square root. So now let's set to work finding the 2 unknown angles. Let's start with angle beta. Since we now know all 3 sides, we could use any of the trig functions. But let's back up and say I don't know this yet. If I only know the 2 sides that are given, which trig function would I have to use? Tangent. So if I look at angle beta here, I know the opposite side and I know the adjacent side. So the tangent of beta is equal to the opposite over the adjacent. The opposite side is 12. The adjacent side is 8. Now I don't want tangent of beta, I want beta. So I have to undo the tangent, I have to get rid of this tangent. You can treat these trig functions as any algebraic operation. And to get rid of it, you just do the opposite, but you have to do it to both sides. So to undo tan, we have to take the inverse tangent, which is found on your calculator by taking shift tangent. We want to do that to this side and to this side. So the tangent cancels out, that leaves us just the angle beta. And over here we have the inverse tangent of 12 over 8. Now watch out, make sure you take the inverse tangent of 12 over 8. Don't accidentally take the inverse tangent of 12 and then divide that by 8. Does everybody see the difference? So make sure you watch out for order of operations. The angle you should get here is 56.3 degrees. Now, to find angle alpha, we could do the same exact thing. Just for angle alpha, what is opposite and what is adjacent is reversed. Does that make sense? But there's an easier way. What other property of triangles can we use to find alpha? Yeah. The sum of all the angles in a triangle have to be 180. We know one of the angles is 90. So that means the other two have to add up to be 90. So we can just say 90 minus the 56.3. Now that tells us that angle alpha is 33.7. Right. Quickly, let's work through one more before we call it a day. Here you're given one side and one angle. And it has to find the other angle and the other two sides. I'm going to start out by finding side A. Which trig function do I need to use? If I know the 25-degree angle and the 8-meter leg there, I want to use the tangent function. Because A is the opposite side. The 8-meter side is the adjacent side. So I want to use the trig function that relates adjacent to opposite. So the tangent of the angle, 25 degrees, is equal to A over 8. Solving this for A, I'll divide both sides, multiply both sides by 8. So I get that side A is equal to 8 times the tangent of 25 degrees. That gives us 3.73 meters for side A. So now let's find side C. Now that I know side A, I can use the Pythagorean theorem just like we did in the first example. But again, I just want to show you some different ways. Let's back up and say that this is the only information that I know, that I haven't found side A yet. What trig function would I need to use using just the information that's given? Cosine. Because I have the adjacent side and I want the hypotenuse. And cosine relates the adjacent, 8 meters, to the hypotenuse, which is C. So now I want to solve this equation for C. You kind of got to be careful when the variable you're looking for is on the bottom of a fraction. Very easy to make algebra errors here. When you solve this for C, you should get 8 over the cosine of 25, not 8 times the cosine of 25. Work this out, and that gives us 8.83 meters. And then to find theta, angle theta, we could use the inverse sine, inverse cosine, inverse tangent. Now that we know all three sides, we could use the inverse of any of the trig functions. Or we could just use the fact that the right triangles angles have to add up to 180. So theta is going to be 90 minus the other angle, 25, which comes to 65 degrees. All right, any questions about these two examples? All right, if you can handle this, you're probably okay with the trig. But make sure that you can handle this easily. Because when we get to the problems where this is necessary, we're going to be focusing on the physics, not on the trig. If you need help with this, there's a trig review with solutions. Come next time with questions about these things if you have questions. You should complete the homework in chapter 1 and these extra practice stuff that I've given you if you need it. And make sure you do that intro quiz so that we know that we're okay with the online quizzes. All right, see you guys next time. Terry, Josh, nice to meet you. You need to be added to the class. No, okay, you're not. Okay, I think you need to be added to something. Have you taken to the student before? The problem maybe with the last one. Because, yeah, so I'll have to look and see if there's a lab. Did you? Yeah, I understand. I'll do what I can, but I can't make any promises.
Yeah, so we don't have to take a lab anymore.
Right, you have to stay registered to this, but if you're registered in, you can't drop it.
Yeah.
I mean, it won't let you drop it. You just need to get a lab feed form. Physics form on this. You know what that is? We go down to the first floor and walk out to the breezeway. The last floor on the left.
Okay, all right, thank you.
Hey, I just want to introduce myself. I'm going to for daughter.
Oh,
Yeah.
okay. Nice to meet you. She helped my fiance quite a bit.
Yeah, Jessica, right?
Right.
Also, I wanted to get into physics 2, sometimes I was going to come talk to you about that, but
Well, I'll have to look at, again, that's like I was telling her, I'll have to look at the lab situation.
Okay.
Because you'll need it in the lab too.
Yeah.
Adding you to the class is no problem, but you have to take the lab and they have a limit on the number of people of actual, you know, they can't have more than 8 people in the lab. So I'll look and see. Email me to remind me if I haven't got back in touch with you soon about this.
Okay, all right, I'll do that.
Okay, thanks.
I just graduated from the med program and I have to take my state board on the 11th for this next year in Jackson, so I won't be in class. Do you know if there's like any type of homework or quiz, or I know we can't make a quiz in business, even if it's something like that.
Yeah, but I mean, that's why you have to drop grades. The important thing is that you don't miss a test, and there's not going to be a test on that day.
And then any homework that's due that day I can do ahead of time.
You can turn it in early, and I'll let you know. And if there's an online quiz, you'll always have 2 or 3 days. So the only thing that could possibly hurt you is if there's an in-class quiz on that day. So hopefully there won't be. I can tell you more when we get closer to that.
Okay.
So,
All right, thank you.
Josh Wetter, nice to meet you. Okay. You taking any other classes this term? That's probably going to help. Just focus on this and get done.